Hey everyone, my name is James, and in this video I'll show you how to generate an entire animated GIF collection based on an existing collection. So let's just say you've already deployed your 10,000 NFT collection, but you want to do more. You either want to airdrop animated versions, or you want to create a spin-off collection, or you want to just completely replace the existing metadata on the existing collection with an animated version. So the tool can be found on github.com/jalagar/generative GIF engine. I actually recorded a whole 35-minute video on how to set this up, what the layers look like, all the dependencies, and all the features here. So I'll assume that you've actually watched that video and gone through all the steps and set up this repo. But this video is really focused on how do you generate a GIF version of a static collection. So a bit about myself, I'm the founder and full-time dev of Fitness Friends, where we're trying to use cool 3D generative art to bring a unique perspective on wellness in the Web3 space. I'm a UC Berkeley grad with 5 years of experience in the industry. I'm an ex-tech lead of a finance firm in New York, and I love creating open source tools and helping people. So let's get started. So the right-hand side is actually Hashlips art engine. So Hashlips is sort of the original creator of a lot of this generative art code, and a lot of people have used his tool to create their static NFT collections. So on the right, we have 4 layers: background, ball, hat, landscape. So there's a bunch of different backgrounds, there's a bunch of different balls, there's a little hat that goes on top. One of the layers is none that I added to basically say that 50% of the time, or 50 weight, the ball won't have a hat. And then the landscape also has a none and has a bunch of different landscapes. So we run the tool and we actually get this output. There are 10 of these static balls. So now after using my tool, you can just feed this data into the generative GIF engine, and you get something like this. Here's 1.png, here's 1.gif. Here's 2.png, here's 2.gif. Here's 3.png, here's 3.gif, and so on and so forth. So let's actually run this again, generate another 10 balls, and then actually see what the steps are to make this work. So as I said before, you'll have to actually have installed all the dependencies and installed GIFski, which generates the GIFs, and also have a somewhat rough idea of how to run the tool. So now we look here, we have images, JSON, and this underscore metadata.json. This is the only file you need to create these bouncing balls. So what we do is we move this over to here. Let's actually just delete all of these. This is from my test run. Ignore this dna.json, I'll talk about that later, and then just drag this into here. And then all you have to do is make sure your global config is set. The total supply is 10, the height and width are 1,000, and the start index, because Hashlips starts at 1, I can set this as 1. But you could also just set this to 0 and start from 0, and it would go 0, 1, 2, 3, 4, all the way to 9. But just for sort of consistency across the two, start index is 1. And then we make sure that the layers folder, let's look at the layers folder. These layers folder look a little bit different than this, because now we're actually going to get a sequence of frames. So it has to look exactly the same as this, with spaces in between, the names. But if you open each one, those are the PNG files. So as I talked about in the other video, for static backgrounds, you only need one PNG file and it will just duplicate those X amount number of frames. But for not static backgrounds, like this multicolor one that changes, you have to include all of them numbered 0 to 11. And same with the ball. So we actually have each frame like this with a transparent background. And then we go into config.js, make sure that our layers config has the layers order, similar to what you do in Hashlips: background, landscape, ball, hat. And then all you do is run make regenerate. So what this does under the hood is it actually looks at this underscore metadata JSON. It recreates the DNA from those JSONs and then recreates the layers and then stacks the layers according to the order and then recreates the sprite sheets, which then get turned into GIFs. So let's see what happens. Let's look at step 2 output. So this is the output. These are the sprite sheets. I'm actually going to make this bigger. These are the sprite sheets that came out of step 2 that were regenerated using the layers that were in the layers folder. And then step 3 is what took these sprite sheets and then turned them into GIFs. So we can see here 1.gif corresponds to 1.png. And there you have it. You can actually look in the JSON. What was created were each individual JSON. This is going to look a little different than the Hashlips one. The name is going to be just #1, description, your description here, image. This is going to be the IPFS image that you upload, image name 1.gif, edition 1, date, those are the same attributes, and then the compiler is a little bit different because now you're using the GIF fork. But that's it if you're using Hashlips art engine. But what if you weren't using the Hashlips tool and you didn't have this underscore metadata.json? You just had these individual JSONs like this. Well, let's go look at what would happen. What we can do is we can just delete everything here, and you can just move these .json files. It actually works without the underscore metadata JSON. You can actually just move the individual ones like this, make run generate, and it will work. The reason why underscore metadata.json is easier is because if you have 10,000 of these JSONs, it's a little cumbersome to move them in there, and it also just keeps everything in one place, and it's just easier like that. What if you used NFT Chef's art engine? So NFT Chef is what I based a lot of my GIF engine on. It has a ton of different features like layering, z-index, if-then statements, legendaries, incompatibilities, forced combinations, etc. And in order for that to work, you actually have to pass in this underscore DNA.json. So this encodes a lot of those complex features that NFT Chef uses, and this is what you need to use to generate everything instead. So what you'll do is you'll run NFT Chef's art engine like normal, and it will output an underscore DNA.json and an underscore metadata.json. And in that case, you need to include both the underscore DNA.json and the metadata.json, and then it'll work fine. So that's just one extra step if you're using NFT Chef's features, because otherwise the layers might not look exactly like you want. One more note with the none layers. So notice how I actually specified in the Hashlips none. Some people were able to generate missing attributes. So basically, instead of having none, you would have something like just no hat layer and no landscape layer or something like that. And the tool actually works, and it will output something similar with no layer. So it actually works having an explicit none layer and also missing attributions. So it will work for both of those. So you can actually speed up this whole process by using multiprocessing. So if you set multiprocessing to true, this will use the processors in your CPU and speed things up honestly twice or 4 times as fast. So on my computer, there are only 8 available processors. So I set this to 8, and then I run make generate. And you can actually see that it's going to be doing 8 of the layers at once, and then it'll also regenerate 8 of the NFTs at once, and this will really speed things up. So just a precaution, only use this if you are aware of how many processors your computer has, and if you are aware of your computer's hardware limits. If you have a bunch of other processors going, or tabs or videos or other high CPU tasks running, this could crash your computer. So I would definitely start with multiples of 2 and only really use this feature if you absolutely have to, or if you're generating a really large collection, or if you have a very, very powerful computer. All right, so let's move on to legendaries. So what if you want to insert legendaries or one of ones into your collection? Well, this process doesn't really work because you can't reverse a legendary one and then also somehow piece the layers together to recreate a GIF from it. So what you have to do is just manually create the GIFs for those. So let's actually do an example. So basically, if you had a JSON that looks something like this, I actually inserted 2 legendary one-of-ones, which are basketball themed GIFs, into the collection. And I look here and I just search up basketball. It's number 2 and number 6. So the tool cannot reverse and create the basketball layers because they're one-of-ones. So what the tool will do is it will actually just skip what it can't understand. I'm going to delete the underscore DNA because this is an old DNA, and pretend we're just left with the underscore metadata.json with these rare one-of-ones. So we can actually see here it says no corresponding layer for 2, skipping assuming this is a legendary. No corresponding layer for 2, skipping assuming legendary, and 6. So when we look at the actual GIFs that get outputted, we are missing GIF 2 and GIF 6. So what you do is you'd actually have to just drop in those legendary one-of-one GIFs, and you can actually see here 2 JSON has basketball and hoop, and 6 has basketball and cupcake. And so we can look at under these ultra rares, I actually have the GIFs for them. We could just drop these 2 in like that. So let's say you need to just generate the sprite sheet. You don't actually need the GIF. Some other metaverses or APIs or other integrations you're doing require sprite sheets and not GIFs. And they actually require those sprite sheets to be in a certain format. For example, 5x5 grid or 10x10 grid or something like that. Then instead what you do, instead of doing step 1, which turns the layers into a sprite sheet, you can just skip that entirely and then only focus on step 2. So here, what we can do is we can set two variables in the regenerate.py file. So this is right here, regenerate.py. There are two variables, skip step 1 and skip step 3. So you can set both of those to true. And then you can run make generate. And what this will do is it will take the sprite sheets in the output folder in step 1 and use those. So it will actually just basically ignore this layers folder entirely. So this means if you do actually want to have a specified format of 5x5 or something like that, you have to format your initial layers into whatever format you want, put them into step 1 layers to sprite sheet folder /output, and then you would format it like this. Note these names have to match exactly with the JSONs that you're putting in. So under here, we have pink and goldfish and purple. We need pink, goldfish, purple for all these things. And if there's a space, you need a space, or else the code can't know which layer to pick. So yeah, you could format these to be 5x5. You could format these to be whatever you want. Put them into step 1 output and do it like this. And you can create a new folder if the output folder doesn't exist, and then run make regenerate with these two flags being set to true for both. Make sure to save the file and then run make generate. Before running make generate, you're going to also have to change the height and width in step 2. So to do this, you go to step 2 /source/config, or you can just do command P config. This is the file that you're also changing the layer config. So right under the layer configs, you'll see format, and then you just manually type how many pixels the input layers are going to be. And then you can run make regenerate. And then in step 2, you can actually find the output right here, output/images like this. And this will be whatever dimension that the input file is in. Finally, the last feature is batching. So in the previous video, I talked about batching, but essentially the limitations of the JavaScript engine can only have 32 frames of 1000 by 1000. So that means if you had 40 frames of 1000 by 1000, or you had 100 frames of 500 by 500 or something, the tool would not originally work. However, batching is how you get around that. So all you have to do is set this use batches to true. The number of frames per batch, this has to be an even divisible of the number of total frames. So 12 is divisible by 4, and then you just save it. And make generate will actually just work like this. You don't even have to specify anything extra. So that concludes this quick video on how to regenerate a collection and actually create the corresponding GIFs for those NFTs. Thank you so much for watching, and please create an issue or discussion item on the GitHub if you come across any of these issues. Follow me on Twitter at @Jalagar_ETH and my project at @FitFriends_NFT. Thanks so much for watching, and hope you have a great day.